Variation. Definition of direct variation. If y equals k times x for some non-zero constant k, we say that y varies directly as x, or that y is proportional to x. We call k the variation constant or the constant of proportionality. The equation y equals kx is called a direct variation equation. Once again, this is variation, and keep in mind it's direct variation equation. So just a quick restatement. Definition of direct variation for y equals k times x for some non-zero constant k, we say that y, there's our y, and how does it vary? It varies directly. So there's a keyword, direct variation, so directly. And it varies directly with respect to x. So y varies directly with respect to x. Or that is, we can also say y is proportional to x. But be careful with the word proportional. You might see it often, but proportional could be a multiplication or a division. But in this case, it's a direct variation, which I'll explain more of whether it's multiplication or division in a minute. So we call k the variation constant, or the constant of proportionality, the equation y equals k times x. So therefore it must be a multiplication. So even though it's proportional, it's a multiplication type of proportional. So it's a direct variation by multiplication. So y equals k times x. Notice both y and x are variables. K is the constant. So this is called a direct variation equation. Once again, just a recap statement, direct variation. And it's y equals k times x, the general format of our equation. And we call it proportional, but be careful, this could be multiplication or division, but for this case, since it's direct variation, it implies multiplication. So direct variation, multiply. So notice that once again, y and x are the variables, and k is a constant. In other words, just a number. So let's proceed and realize once again, this is talking about direct variation. And the fact is, to find and use a direct variation model, assume that the quantity p varies directly as a quantity t. 1. Substitute the values of a data point into the equation p equals k times t, then solve for k. 2. Substitute the value of k into the equation p equals k times t, and 3. Use the equation to make estimates for p or t. Examples. So we have in this case our examples for a. H varies directly as d. Notice that it's simply written as h equals k times d. So once again, direct variation, proportional, or in other words, multiplication, right? Direct implies multiplication. So in this case, for the first example, a, h varies, and how does it vary? It varies directly. So there is our word, keyword, directly. So it means we're going to multiply. And it varies directly with d. Which one came first? H. H came first, so therefore h equals. And h equals, in this case, our other variable is the d. It varies directly as d. And our constant, of course, is k. So let me just write in blank right here on the right side. For a, h equals k times d. So there is our equation, but we don't have anything else to use as a reference to find what our constant is in this case for the k. So let's go on to the next one then. B. For b, y varies directly as x plus 6. Therefore, our equation becomes y equals k times in parentheses x plus 6. Be aware of that. So what came first? Y. And how does it vary? It varies directly. Directly with respect to what? X plus 6. Do be aware of that. It includes an expression, not just a variable in this case. So therefore, y equals k times the constant, or in this case, pardon me, our constant times, in parentheses, x plus 6. Yes, do remember the parentheses, because that all is taking the place of our variable. So it's all be multiplied times k. So our full or final restatement of our answer, B, is y equals k times in parentheses x plus 6, and then close your parentheses. So there's our equation, but we don't know once again what k is. Let's stay tuned for the next problem, where we do know how to get the k value. So for C, z varies directly as r squared, and z equals 9 pi when r equals 3. So essentially, we have z equals k times r squared. So how does it vary once again? Z varies directly. So we have z equals, right? And what does it vary with respect to? It's r squared in this case. So there's our r squared. Now the next portion of our statement is pretty much giving us a coordinate point when z is 9 and when r is, that will give us r is 3. And in some cases, you may get a question such as, what is z when r is 25, for instance, okay? But we don't have it in this case. But for this one, z equals k times r, and it's r squared, once again, are two set variable forms. Okay, so just copying and clean on the right side, see? We have z equals k times r squared, and once again, let's realize that they gave us two coordinate values, right? Or a coordinate point in this case. Z equals 9 pi, and that's going to replace the location of z, and when z equals 9 pi, we also know r equals 3, and that's going to take place of our r. So replacing them, here's what it looks like now. We have 9 pi equals k times 3 squared. 3 squared, 3 times 3 gives us 9, right? So there it is, 9 pi equals k times 9. Solving to find the value of k, divide by 9. There it is, and notice the 9's cancel out, giving us a 1 technically, so 1 times pi, or k times 1, or just simply k, right? So pi equals k in this case. We found the constant here, so we're able to replace the k value with our constant. There's our full equation. This will be our full equation that we can use for any other specific case if needed. So there would be our answer for what is the equation.